All right, everybody, this was my first ever video working with circuits. So, fairly new. The video is not that great, but hopefully you guys will get the point. When I first started this, my circuits class, I did direct current circuits. I'm now in alternating current circuits. But when I first started, I could not do anything. It was either too simple or too hard. Some people would do these proofs, and I would just be blown away. And I'm like, okay, how do I take that and apply it? What I needed was calculations, just simple equations that I could plug in and figure this stuff out. Unfortunately, there's not a whole lot of that out there. And what is, it's usually a person that can barely speak English. No offense to the Indians, they're great, but I can barely understand you guys sometimes, and it can be difficult. Other times, like I said, they make it overcomplicated and do these, like derivatives and super stuff. I know how to do derivatives, but I need it broken down Barney style for me. Or they would make it too easy. They would just give you like the basic power equation and be like, okay, there you go. That's all you need. So what I vowed to do was to go over that stuff. So in this video, I'm going to go over Ohm's law, or his equation actually. We're going to take those equations from Ohm's law and just do step by step on how to do this stuff. Then we're going to go into the same thing with power. So we're going to take the power equations step by step, same exact thing. And then I'm going to calculate the efficiency. I'm going to show everybody how to do that and the equation for that. Then we're going to go over to the equation for calculating kilowatts an hour. And then after it's all said and done, I'm going to go over some practice problems that I picked out of my old textbook. That way you can get, you can stop the video at any time, do it yourself, or you can follow along and see that process. Hopefully that'll help people out and they can see like real time how somebody worked that out and they can reverse engineer that, but we'll see. Anyways, here's the show. All right, here we go. I have my monster and I have my equations. Now I got to figure out these circuits. What are we going to do? Well, we actually have three equations that we can use at our disposal. That is, current is equal to voltage over the resistance. We also have voltage is equal to current times resistance. And lastly, we have resistance is equal to the voltage over the current. So using these three equations, what we're going to do is we're going to solve these three problems I just made up. All right. So first off, we'll start out really basic. We have a 10-volt DC battery pushing some current through this resistor, a 5-ohm resistor. What equation are we going to be using? So if you think you have this figured out, go ahead and pause it and try to do it on your own. If not, let's try it. All right, so right now we have our we have one unknown, which is the current, and we have two unknowns. So we have current unknown, voltage is equal to 10 volts, and we have our resistance is equal to 5 ohms. Given that, that's our first equation right here. What we'll do is we'll calculate this. So current is equal to, what is going on? 10 volts over 5 ohms. All right. I shouldn't need a calculator, but I don't want to mess this up. I'm going to throw it through a calculator regardless. All right. So that would be 2 amps. All right, moving down. So this one, I should have wrote this out, that we have a potentiometer, and we need to adjust it to, or we need to double the amount of ohms. So if we double the amount of ohms on our potentiometer, so that's our potentiometer right there, and we double our amount of ohms, what voltage will we get? So again, let's look at our equations. Which one would we use? One thing we could always do is list out the unknowns. So we have voltage. That's unknown. We have current. That's equal to 1 milliamp. And we also have our resistance, which is double of 2.5, which is 5 ohms. So again, I should have written that out, but I guess would be the correct grammar. But anyways, what equation will we be using? Equation number 2. So we know that the voltage is equal to 1 milliamp times 5 ohms. Again, probably a lot of people probably do this in their head, but I don't want to make this video over again. I messed up the last one. Don't want to try it, or I don't want to do it. 1 milliamp times 5. We have 5 millivolts. 5 millivolts. Yeah, that sounds about right. That looks right. All right. So moving on to number 3. Let's say the textbook that you have just throws something crazy at you, like you have a 5-volt battery that you have to double, and you know that you already have a 10 milliamp current. What would be your resistance? So let's again list out the variables. So voltage, we double the voltage, so that's 10 volts. Current, 10 milliamps, and resistance is unknown. So if we go up here, which one is our variable that we're missing? Number 3, right here. So what we do is we make our resistance is equal to the voltage of 10 volts over 10 milliamps. So we 10 divided by 10 times our 10 second E to the negative 3, and that gives us 1, the screen moved on me, 1 kilo ohm. All right, moving on to power. So with power, we have 3 different equations that we'll be using here as well. Power is equal to voltage times current. It is also equal to current squared times resistance. And our third equation will be power is equal to voltage squared over the resistance. All right, so we'll use these 3 equations for the 3 examples I have below. And then we'll go into some other stuff. All right, what do we got? So we got 9 volts, a 9-volt battery. We have 100 milliamps. Let me rearrange that real quick. So voltage is equal to 9 volts. Current is equal to 100 milliamps. We want to know the power. What is the power? So what we do, we use this first equation right up here. We take our power, make that equal to 9 volts times 100 milliamps. What does that give us? Again, I could probably do this in my head, but I don't want to mess it up. E to the negative 3, 900 milliwatts. Boom. All right, so let's figure out what the resistance is to double check our work. We want to make sure that this is correct. So to find the resistance, if you guys recall, we take the resistance is equal to the voltage over the current. So we just quickly calculate that. Whoops. Quickly calculate that. So we have the voltage is equal to 9 volts. Current 100 milliamps. And then the resistance is unknown. Take a moment, pause this video, and see if you can figure it out. All right, so if you haven't figured it out, we're going to do a step-by-step on how to do this. First, we need to find out what our resistance is to double check what our power should be. So the resistance is equal to 9 volts over 100 milliamps. So we take 9, divide that by 100, second e to the negative 3. That gives us 90 ohms. So that means that this right here, that right there, is 90 ohms. Now, we can use our second equation to double check to see if this one was right. So what we're going to do is we're going to take power is equal to 100 milliamps, square it, and then multiply it by 90 ohms, that is. So 100 times second e to the negative 3 squared times 90. Boom. 90 milliwatts. Good job, everybody. All right. This one, I thought we'd throw in a word equation just so that way we can mix up a little bit. A direct current circuit has a 6-volt battery and a 5-ohm resistor. You are told to double the voltage and calculate the power. All right, let's try that real quick. First off, let's just draw this thing out. So we have our DC battery. We'll start it off right there. Go up, around, it's a simple circuit. Down, we had our messed up resistor. Come down, over. All right, and we know this is a 6-volt and a 5-ohm resistor. All right, simple circuit. And we need to know what the power is. So we know what the volts are. A volt is equal to 6 volts. And then we have the resistance is equal to 5 ohms. All right, so looking up here, we're going to use our final equation. Number 3, power is equal to the voltage squared over the resistance. So come down here, put our power is, whoa, this program can be a little bit difficult sometimes to work with. It's equal to the voltage squared over the resistance. There, okay. However, let's not lose track. This is what happens to me when I get too busy. We're told to double, see that? Double the voltage, then calculate the power. So this isn't 6 volts. Oh no. This is 12 volts. So now that we've doubled the power, doubled the voltage, we can calculate the power. So power is equal to 12 volts squared over 5 ohms. Pull out our handy calculator. 12 squared divided by 5 is equal to 28.8 watt. Okay, some other things we're going to cover is efficiency. So, efficiency is this crazy looking thing right here, right? Is equal to the power output over the power input. Now, that crazy looking thing right there is called eta. It is a Greek symbol, and it is called eta. So the eta, or the efficiency, in percentages is equal to power output over the power input. All right, so say we plug an electric device in the wall. You then measure the output power of 5 watts. You know that the input power is 6 watts. What's the efficiency? So with this equation up here, we know that the efficiency, well, let me draw the crazy Greek sign correctly. The efficiency is equal to 5 watts over 6 watts times, I forgot to do over here, this is times 100. Times 100. So, that's how we get a percentage. Alright, so if we take 5 divided by 6 times it by 100, 83.33333%. 0.3 repeating percent. Alright, that's how we find the efficiency. Alright, so let's look at this one right here. So we want to calculate the energy used for a washer and a dryer, which both use 3,600 watts of power for 1 hour and a half. Alright, this is the equation that we will be using. It calculates kilowatts per hour. We got 3,600. You want to times that by 2. What do we get? 3600 times 2 is equal to 7.2 kilowatts. No, not that type of W. It has to be the other W. Again. Then we'll get more into the nice cursive W later on. So, right there, we have 7.2 kilowatts. And we got to go over the period of time, so 7.2 kilowatts multiplied by the time, and we know it's for an hour and a half, so 1.5 hours over 1,000. And that will get us our energy kilowatt an hour. So take 7.2 kilowatts, multiply that by 1.5 hours, divide that by 1,000, and we got 10.8 kilowatts an hour. All right. Okay, so I picked out some problems from one of my old textbooks, and we're going to take a look at that now. We should know how to do all these. We just went through the demonstration. So let's get started. All right, so we know that voltage Actually, let's look back. What are we looking for? We're looking for current. So current is equal to voltage over the resistance, 2.2 ohms. So there, calculator, 12 divided by 2.2, so 5.45 amps. All right, so right there, 5.45 amps. All right, now looking right here, what are we looking for? So we're looking for the volts. So we know voltage is equal to, what was it equal to? Current times the resistance. So we know current times the resistance. So the current was 65 milliamps times the resistance of 100 ohms. That's why it's good to memorize this stuff so you don't have to do this during a test. But I'm horrible at memorization, so forgive. 6.5 volts. All right, now we're looking for the resistance. So we know resistance is equal to volts, 11 volts over 500 micro amps. So 11 divided by 500, second e to the negative 6. That'd be 22 kilo ohms. All right, now we're looking for the power. Let's go take a look at our power equations real quick. Okay. So this one we're given current and voltage. So current and voltage. First one right there. So power is equal to current, 600 microamps times 24 volts. 600, second e, negative 6 times 24. That gives us 14.4 milliwatts or milliwatts. All right, still looking for power. This time we have resistance and current. So we have resistance and current right there. Power is equal to the current, I believe it's current squared. Yep, current squared times the resistance. So 420 microamps squared times the resistance of 150 kilo ohms. So it's 420, second e, negative 6 squared times 150, second e to third. I got 26.46 milliwatts approximately. All right, now we're looking at voltage. Go back over here. voltage squared over resistance. So power is equal to the voltage squared, 120 squared, over the resistance. That's 28. Oh, did I mess it up? I think I messed it up. Yep, voltage squared over the resistance. Let's go back. Oh, I think I got it right. 28 squared over 120 kilo ohms. See, I made a mistake right here. Let me fix that. So it's you got to make sure that you put what you're calculating. I've seen a lot of teachers grade somebody wrong or give you half credit because you didn't use the right variable. All right, so 28 divided by, oh, that's 28 squared. Squared divided by 120. 6.53 repeating. Watts. Oh, wrong type of W. Watts. All right, so if you remember this equation, you have your power output, power input. Let's go back over here. Power output, power input. So our power output is 36 milliwatts over 2 watts. That is equal to, oh, and then you gotta, almost forgot, gotta multiply it by 100 in order to get the percentage. So 36 second E3 divided by 2 times 100. 1.8%. All right, sorry, slight distraction, but let's get back into it. A 24-volt power supply for a backyard light system can provide a maximum output current of 8 amps. The light designed to be used with the system contains 5-watt lamps. How many lights can be connected to the power supply without exceeding 80% of the maximum power rating? Okay. So first, I think we need to list out our variables. So we know we have 24 volts, 8 amps, and we need to find the power. And with that power, we have to find the 80%. So power times 0.8. It's a little times right there. Times 0.8. That'll give us our maximum power. And then we have 5 watts. 5-watt lamps. All right. So what we need to do, if we remember that to get the power, move this over a little bit. To get the power, we need to take 24 volts, multiply that, actually do it like that, multiply it by 8 amps. That's going to give us our power. So 24 times 8. 192 watts. So it's maximum. Now, that's how much power we have. 192 watts. Now we got to multiply that by 80%. So 80% of 192 of the power is 153.6 watts. All right, and we know we have 5-watt bulbs. So how many can go into here? So we take that number and just divide it by 5. So we come up with 30.72. However, the watts cancel out. However, if you look at it, you can't put 0.72 of a light bulb in there. So the number would just be 30. So that would be the answer. 30 light bulbs. So I need to calculate the max allowable setting for the voltage source. Max allowable setting. Well, we can use a power equation that we already know. So we go power is equal to the voltage squared over the resistance. So if we use this, what we can do is just plug and play with this stuff. So 1/2 watts, oh, wrong type of W, remember. I'll explain more about that later. 1/2 W is equal to voltage squared over 22 ohms. All right, now next what we do is we bring it over. So 22 ohms over 2 watts is equal to volts squared. Well, we know that is equal to 11. And I'm going to drop the, what is it called? The variables real quick. To get rid of a square root, or a square, we have to square root both sides. So that means voltage is equal to 3.316 and some change. So if we round out, that's voltage is equal to 3.32 approximately. All right, that would be the maximum allowable setting for our voltage. All right, everybody. Thank you all for watching. Again, this was meant so that way people didn't end up in the same situation I was. I was really looking for different types of videos, couldn't find them, so it doesn't exist to my knowledge. Hopefully this type of video will help somebody else out, and if not, it's cool just me making these videos. But anyways, thank you. I will be working every Sunday to make a new video on the direct current circuits, and hopefully somebody gets something out of this. Thanks. Have a great day.